Okay, this is primarily for Dija, but anyone else who wants help with these. I'm going to go through June 2019, the AS Pure paper, just some of the questions. I'm going to go through 5B, 6, 8, 10, 12 and 16. So 5B, 5A was just differentiate an expression, that's your differential. 5B, you had to find out what values of x give you an increasing curve. So if this is the differential, this is the gradient. For the curve to be increasing, the gradient has to be more than 0. So 6x minus 24 over x squared has to be greater than 0. Probably the best way to work that out is to move the 24 over x squared across to the other side. Multiply everything by x squared. You can do that because you know it's positive, so you're going to have 6x cubed is greater than 24. So x cubed is greater than 24 divided by 6, which is 4, so x is therefore greater than the cubed root of 4. You can have an equal sign there as well if you want. So I've got to flip through the questions on my sheet as I go. That's 5B, right? Question 6. Just quickly sketch the diagram. That's 2x, that's 3x, that's 60. You're told the area is 18 root 3. The area of a triangle is half AB sine C. So that's the formula for the area of a triangle. So for these values, you've got half times 2x times 3x times sine 60. And they tell you that that equals 18 root 3. So we have got half times 2 times 3, which is 3x squared. The sine of 60 is root 3 over 2 is 18 root 3. So x squared is 18 times 2, 36 divided by 3 is 12. So we can cancel the root 3's. 18 times 2 is 36 divided by 3 is 12. So x squared is 12. X is the square root of 12, which we can rewrite as 2 root 3, which is what they wanted you to show. So that's part A. Part B, hence find the exact length of BC, which is this side here. Let's call that A. If we know this length, and we know that length, and we know that angle, we want to find that length, and this looks like cosine rule. So A squared equals B squared plus C squared minus 2BC cos A. So A squared equals, well, if x is 2 root 3, then 2 of that is 4 root 3 squared, plus this one, which would be 6 root 3 squared minus 2 times 4 root 3 times 6 root 3 times cos of 60. And that's now just buttons on your calculator. So this is going to be 3248 plus 367208 minus 3 so 24 times 3 48 72 144 cos 60. I'm just churning numbers out here. Eventually you should get the answer, which was 2 root 21, or 84, sorry, square root of 84. Question 8. So again, I need to just pull up the questions. Question 6, question 7, question 8. There we are. 8b. Yeah, a lot of people struggled with this. So you've got an expansion of 2 plus 3x over 4 to the power 6. And the expansion you've got, the answer you've got for that should be 64 plus 144x plus 135x squared. So that should be your answer from A. Now, if you want to use this to work out what 1.925 to the power 6 could be, then clearly this thing has to be the same as that thing in order that you can use this. So if 2 plus 3x over 4 equals that, 2 plus 3x over 4 has to equal 1.925. Then 3x over 4 has to be 0.075, so x, so that's a minus, has to be minus 0.1. So you just need to put minus 0.1 into that, and that'll tell you what your approximation is. All right, question 10. Just find question 10 on my screen. So part A, well, you've got the equation of a circle, x squared plus y squared minus 4x plus 8y minus 8 equals 0. In order to work out what the centre of the circle is and its radius, we need to rewrite this in this form. So we need to work out what those two things are. So we need to get it from this form into that form. The way to do it, look at our original one. Let's pair up the x's. So I've got x squared minus 4x. Pair up the y's. I've got y squared plus 8y minus 8 equals 0. Okay, just look at the x's. I'm going to do a bit of completing the square. So that would be x minus 2 squared. If I multiply this out, I'd get x squared minus 4x plus 4. So therefore I need to take away 4 to make it equal to this thing. Similarly with the y, that's going to be y plus 4 squared. I need to take away 16. Take away the 8 equals 0. And if I rearrange all of this, I get x minus 2 squared plus y plus 4 squared equals 16, 24, 28. So therefore the centre of the circle is 2 minus 4, and the radius is the square root of 28. Excuse me, which we rearrange to be 2 root 7. So we can do a quick sketch of this. Centre is at 2 minus 4, let's say it's approximately there. Radius is 2 root 7. You've got two lines which are tangents, and they have equations x equals k. K can have two values, let's call it k1 and k2. We need to work these two out. Well, they're tangents, so they cross the line there, and this distance here is the radius of the circle. So therefore you just need to take the x value for the centre of the circle, which is 2, and add on the radius, which will give you that, or take away the radius, which will give you that. Okay, question 12. Just find it on my screen. Okay. Bit of trig identities. 10 sine squared theta minus 7 cos theta plus 2 divided by 3 plus 2 cos theta, and that's equivalent to 4 minus 5 cos theta, and you need to prove that. Presumably at some point we're going to be using that. On the right hand side you've only got coses. On the left hand side you've got coses, but you also have a sine squared, and ideally I'd like just to have coses over here. So the first thing I'm going to do, I'm going to use the identity that sine squared theta is 1 minus cos squared theta. So let's substitute that in. 10 times 1 minus cos squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta. I need to show that that is the same as 4 minus 5 cos theta. Alright, let's multiply this out. So I've got 10, take 10 cos squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta. Show that that equals 4 minus 5 cos theta. Sort this out a little bit. Let's have minus 10 cos squared theta minus 7 cos theta. 2 plus 10 is 12 over 3 plus 2 cos theta. That's the same as 4 minus 5 cos theta. Alright. We've got a quadratic on the top here, but it's a quadratic in cos, but you solve it in exactly the same kind of way. So we've got a solve quadratic. You could use all sorts of methods. You could use your calculator, but I'm going to try and factorize it. It's a minus cos squared, so I'm going to have minus 5 cos theta plus 4, 3 plus 2 cos theta. So this quadratic factorizes to that. And what you'll notice is that you've got the same thing top and bottom, so you can cancel them. And you end up with that, which is the same as that. So we've done 12 part A. 12 part B, we have to then solve for this thing equals 4 plus 3 sine x. Well, that's really complicated. It'd be much easier just to use that instead. So we're going to replace this for 4 minus 5 cos theta, and that's equal to 4 plus 3 sine theta. I can use trig identity sine over cos as tan. Let's get rid of the 4's first. Divide everything by cos, so I've got minus 5 equals 3 sine x over cos. Sine x over cos x is tan, divided by the 3 minus 5 over 3, and then I'm just going to do arctan, shift 10 on my calculator to work out what x could therefore be. And number 16. Sorry, dear, I just need to scroll through my questions. Okay, number 16. It tells you for two particular vectors that the size, the modulus of A plus B, is the same as the modulus of A plus the modulus of B. Well, let's just pick two random vectors. There's one, let's call it A, and there's another, let's call it B. So this is A plus B. And for this particular one, the length of A plus the length of B, that total length there is obviously going to be more than that, isn't it? This is the length of A plus B. the length of this is not the same as the length of that plus the length of that. So for this particular diagram, that is not true. You might be able to see that the only way to get this to be true is if A and B follow on from each other. So if A was like that and B was like that, then the length of A plus the length of B is the same as the length of A plus B. So your answer is, for that to be true, that A and B have to be pointing in the same direction. Part 2, you've got two different vectors, m and n. So modulus of m is 3, let's call that m, and this is 3. And m take away n is 6, so let's have m take away n here. M take away n, that's equal to 6. We know the angle between m and n, so n is going to have to be there. So that's 30. We need the angle between m and n, m minus n. You need to find that one. We're just going to use a little bit of sine rule for that one. So we're finding an angle sine A over A, oops, equals sine B over B. Not a great diagram. The answer sheet gave a better diagram, but that's how you construct it. And then just use a bit of sine rule. I hope that helps, dear.